practice identifying our reduction and oxidation reactions. So we've got a redox reaction here of copper oxide reacting with carbon monoxide to create CO2 and pure copper metal. This is a very common type of reaction where some kind of metal ore is reduced to get a pure metal. So hopefully that provides you a little hint on what's getting reduced over here. But let's use our rules and go through and identify what are our oxidation states here. Well, O right here, that's going to be a -2, right? And we have a rule for that. We don't have a rule for copper, but we can figure that out because it's bonded to that oxygen. Our total for this neutral compound has to be 0. So it's going to be a +2. Great. And this O right here, that's also going to be a -2. And so this carbon, that has to balance out that -2 with a +2. Should make sense. Now over on the other side, our oxygen is once again a -2, and we've got 2 of them, so that would be a total of -4 for the oxygens. And this carbon would have to balance that out with a +4. Okay? And then copper right here, that's monatomic, so it's going to be 0. So what was reduced and what was oxidized? Well, the copper went from a +2 to a 0. So copper is my red. Now my carbon went from a +2 to a +4. It increased in its charge. So the carbon is oxidized. Fantastic. Now looking at our iron ore, oxygen, that's going to be a -2, just like it was before, right? Well, and we can kind of see here that this is going to be iron as an ion, so that iron, that's going to be a +3. And we could do our math and balance these out, but we already know these ionic charges from when we did ionic bonding. Now H2, that's going to be monatomic, so that's going to be 0. And on the other side, Fe, that's going to be monatomic, so that's going to be 0. Then we've got oxygen as a -2 and hydrogen as a +1. So look at that. What was reduced? Well, the iron went from a +3 to a 0. So iron was reduced. And then what was oxidized? Well, the H2, that went from a 0 to a +1. That increased in charge. So the hydrogen was oxidized. There we go. So let's talk about some terminology in these types of reactions. It's pretty common to talk about what is being reduced and what is being oxidized. So we've got something being reduced and something being oxidized. But it's very common to talk about certain chemicals that are very strong oxidizing agents. When something is oxidized, it often releases a lot of heat, and that can cause fires. And so in chemical storage rooms, we talk about something being an oxidizing agent. So we have to keep in mind that as this reaction is proceeding, these elements are interacting with each other. They're causing these changes to each other. So iron is reduced, but iron is reduced by the hydrogen. The hydrogen is oxidized, but the hydrogen gets oxidized by the iron. So we could say that in this reaction, we'll say the iron, just for our example here, our iron is reduced, which again means its charge is lowered. And the iron also played a role in oxidizing the hydrogen. And so we say the iron acted as our oxidization agent. Okay? Likewise, the hydrogen was oxidized, right? That meant its charge increased. And so the hydrogen is what reduced the iron. So the hydrogen is the reduction agent. And you might see this as oxidization agent or oxidizing agent or the reducing agent, things like that. But we should be able to pair these all together and say, when the charge goes down, that substance was reduced and it oxidized something else. It was the oxidizing agent for something else. And when charge goes up, that substance is oxidized and it is the reduction agent for another chemical. So let's apply this to another context. Okay, let's look at combustion again. Combustion is a fantastic reduction reaction. So let's do something different than we've done before. Let's do C2H8. So here's our balanced reaction. And let's try to identify the reducing agent. Okay, so let's put this in. Let's put this in purple. A reducing agent and our oxidizing agent. So in order to do that, we need to identify our oxidation states. For this O2 right here, that's easy. It's going to be 0 monatomic. For this hydrogen right here, it's going to be +1, right? Well, +1 times 8, that's going to be 8. And then C2, we need to get that down. How many carbons do I have? 2. So take that +8 divided by 2. So +8 divided by 2 equals +4. So this carbon has to be +4. All right. On the other side, classic, we've already done this before. This should be -2, making this carbon, I'm sorry, this should have been -4. Right, and then this carbon would be +4. There we go, that makes more sense. And this oxygen is -2, and these hydrogens are both +1. And so here, whose charge went up? Well, carbon's charge went up. So that means carbon is oxidized. So carbon is oxidized. And then whose charge went down? Well, oxygen's charge went down. So oxygen was reduced. So who was the reducing agent? Who caused something to be reduced? Well, that would be carbon. Carbon caused oxygen to be reduced. And carbon itself was oxidized. And so who's the oxidization agent? Who's the oxidizing agent? That would be oxygen. Oxygen is the oxidizing agent because it caused carbon to become oxidized. Okay? So we kind of have this crisscross pattern. And we do that because when something is reduced, we're talking about what's happening to that element. When we talk about the agent, we're talking about what it does to other elements. And so this is very important when we have chemicals in storage to be able to identify if something's a reducing agent or an oxidizing agent, because we need to keep those away from each other.